Greetings, welcome to Self-Assessment 7, Problem 4, Part 2. Okay, so picking up where we left off, we're going to answer a bunch of questions about the graph that we produced back in Part 1, or Part A of this. In other words, if we come back here and take a look at this graph, let's get the right spot here, that's the graph that we're going to be asking all of the questions about. Okay, that's logarithm base 3 of x. Okay, so the first thing we want to know is what is the domain of x? Okay, so again, recall this is g of x is equal to logarithm base 3 of x, okay? And the domain of this function, the domain of the function, if we go back and we take a look at the graph here, what we notice in the graph is that we start at 0 and then we head out to positive infinity. And again, recalling from the first part of the discussion, we realize that the y-axis is a vertical asymptote. So we're going to get as close as we ever want to 0, in other words, letting x go to 0, but it's never going to quite get there, okay? So what that means is that the domain of g of x are x's strictly greater than 0. Excuse me, I wanted to do that in black, so let's come back over that. So x is strictly greater than 0. So in interval notation, though, which is probably a good way of doing that, that would say that we're going to go what? From 0, endpoint not included, out to positive infinity. Okay, what is the range of g of x? Okay, well, we talked about that in the last video too. We know that this is going to negative infinity in this direction, and we're eventually, although it takes a long time to do it, we're heading up towards positive infinity in that direction. So with respect to the y values, the range of g of x, we know that negative infinity is less than y is less than infinity. Or you could have put in here, of course, a g of x in place of the y. That probably would have been more appropriate. In interval notation, you get what? Negative infinity to positive infinity. Okay, for what values of x is g of x positive? So they're asking you for what values of x is the function above the x-axis. So they're asking you for this part of the graph where it's above it. So what values of x does g of x stay above the x-axis? Well, that's going to be for x is greater than 1. So if x is greater than 1, g of x stays above the x-axis. Or we could do that in interval notation. It goes from 1 to positive infinity. For what values of g of x, for what values of x is g of x negative? Well, that's going to be in the interval between 0 and 1. Notice that we don't go past 0 with respect to the x's, but for all of these values, notice that the y values are now below the x-axis, which makes them negative. So that would be for the values of x between 0 and 1. Or in interval notation, that would be from 0 to 1, endpoints not included. Because being positive means you are not 0, being negative means you are not 0, because 0 does not have a sign. It's both positive and negative at the same time. So for what values of x is g of x increasing? Well, notice as if you are walking along this line, you are always going uphill, aren't you, as you move from the left to the right. So no matter where you're at on this graph, you are increasing over the entire domain. So if you move from the left to the right and walk up it, notice we are going up. So g of x is increasing on the entire domain of the function. So what was the domain of the function again? Oh, it was from 0 to positive infinity, or again, as in the upper one, is from x is greater than 0. What is the vertical intercept? Okay, so the vertical intercept means we're asking where does it cross the y-axis, right? So that's the y-intercept. And remember that this particular graph has the y-axis as a vertical asymptote, so it does not exist. There are no vertical intercepts of this graph. Well, what about the horizontal intercept? Again, we talked about this in the previous video. We know that it crosses through the x-axis at 1, 0. So if we go back here, crosses at the horizontal intercept is at the point 1, 0. Now, this is one thing to make sure you keep in context is that, remember, these up here were interval notation. Those aren't points. This is actually a point. I'm actually saying that's this position right here on the x-axis. Okay, give the equation of the vertical asymptote for g of x. Well, the equation of the vertical asymptote is the equation of the y-axis, which is x equals to 0. For what values of x is g of x equal to 1? Okay, so that's asking us to solve the following equation. G of x equal to 1 says that logarithm base 3 of x is equal to 1. And so as we did on one of the earlier questions here, we're being asked to solve this equation by using the inverse to the logarithm, which is the exponential. So the exponent on a 3 that gets me x is equal to 1. So the exponent on a 3 that gets me x is equal to 1. So that would say that x is equal to 3. In other words, checking that solution, logarithm base 3 of 3 is equal to 1. For what values of x is g of x equal to 3? In other words, for what values of x does logarithm base 3 of x equal to 3? Okay, so that's saying the exponent on a 3 that gets me x is equal to 3. In other words, changing this back into exponential notation, that says 3 cubed is equal to x. So if 3 cubed is equal to x, then what does that say? Well, that says that x must be equal to 27. Okay, determine g of 42. Round your answer to 3 decimal places. Okay, so g of 42 is going to be logarithm base 3 of 42. Well, we'll use the change of base theorem to help us out here. So that's going to be logarithm, common log, of 42 divided by common log of 3. So let's go ahead and use our calculator to do that. So we're going to take common log of 42, and then we'll divide that by common log of 3. Good idea to have the change of base theorem memorized if you have not yet done that. Notice we use that quite a bit. So if we take it out to 3 places, it would be 3.402. So this is going to be approximately, I'll put squiggles here, 3.402. Okay, well hopefully all of that made sense. This is a really nice cumulative review of the properties of logarithms. So if you have any questions about these, please do not be shy about posting questions to the Q&A forum.